Yes, Subbu. Assalamu alaikum. How are you?
Walaikum assalam.
All right. So in the previous class, we were discussing about temperature scales, right now. So in this, we already studied about how do we convert from the Celsius to Kelvin scale and from Kelvin to Celsius scale, right? Okay. Do tell me, how do you convert? How do you convert from Celsius to Kelvin? In order to convert from Celsius to Kelvin, what you would be doing? You understood my question. I believe you might have understood my question.
No, sir.
My question is that you are provided with a temperature in degree Celsius. आपको एक temperature degree Celsius में provided है. You have to convert from Celsius to Fahrenheit, Celsius to Kelvin. What you should do? It's a simple question. In fact, पिछली क्लास में हमने डिस्कस किया था. We did discuss this in the previous class.
Subtraction.
Subtraction. How much has to be subtracted?
273.
273. Very good. Okay, now 273 has to be subtracted, or should it be added?
Subtracted.
You won't be subtracting it. You have to add. You have to convert from Celsius to Kelvin. Then you have to add this, right now. तो अब आपको
Yes.
add करना है. Okay. While if you want to convert from Kelvin to Celsius, then you have to subtract 273. Just like this one. The freezing point of water was given 273. So thereby आपने इसे Celsius में convert करने के लिए you simply subtracted 273 from this and then you got 0. Okay now. So hope you are able to understand this. Why others have not joined the class yet? Okay. There are other formulas which we are going to study today. The ones which are important for you, I'm highlighting that one. See, today we'll be studying about how to convert from Fahrenheit to Celsius and how to convert from Celsius to Fahrenheit. Conversion of Fahrenheit to Kelvin. As of now, this much is not very much important, but logically you can understand that one also. But as of now, if you remember this much, that will be sufficient. That will be more than sufficient for you guys. So let others also join before I continue this. Meanwhile, you can answer a few questions to me. Do tell me, what are the precautions you would be taking while taking measurement from a laboratory thermometer? And what are the different units of measuring temperature?
So Celsius, Kelvin, Fahrenheit.
Celsius, Kelvin, Fahrenheit. Very good. Okay. And the first question. Answer to first question. What precautions you would be taking? This question is asked in the exam.
Sir, you have to not touch the beak of it. Sir.
Bulb.
Yes, yes, sir. You have to not touch it.
Okay, bulb should not be touched. And what else? और क्या हमें precaution लेना होता है?
We should not cool. We should not heat it then directly cool it.
Once you have,
It will break.
it will break. Very good. How you should be holding the laboratory thermometer?
We should not touch it by the we should just not touch it by the.
We should not touch the glass. Okay. Now.
Yes.
Then how should we touching it? With the help of a holder, you would be holding it. Okay. How you'd be keeping it? Will you be keeping it horizontal, vertical, or tilted?
So you have to keep it horizontal.
Horizontal. Horizontal means like this, not like this.
It's like straight.
Like vertical. That is called as vertical. In this manner, you have to hold it. Okay, now vertical. Okay. So that is the thing. Also, how you should be taking reading while the thermometer is dipped in the liquid, or while you have taken it out from the liquid. Yes, Priyanka, how are you?
Fine, sir. How are you?
Yeah, I'm also good. Okay. Please try to join the class on given time, Priyanka. Okay.
Okay, sir.
So right now we are discussing few basic things. In the previous class now we have already discussed about how do we convert from Celsius to Kelvin. Hope you guys have memorized that and how to convert from Kelvin to Celsius. Today we would be learning about how to convert from Celsius to Fahrenheit and from Fahrenheit to Celsius. You have this formula also, how to convert from Fahrenheit to Kelvin and from Kelvin to Fahrenheit. Although as of this class 7, the standard, studying about this much will be more than sufficient for you guys. Okay, now? So this one we won't be discussing, but logically, you can understand that it's not that much difficult. Right now, I'm asking few basic questions. Like we should be holding the laboratory thermometer in a vertical position. Okay, what is the range of reading of a clinical thermometer?
36 degrees Celsius to 42
No,
degrees.
no, it isn't from 36. It starts from Yusabu.
35.
Hmm. It starts from 35. Very good. Okay. Which one of them has a king? Laboratory
Critical.
or clinical? Clinical
Cleaning.
thermometer. Good. Okay. Now these days we are using which type of thermometer? What type of thermometer we use these days?
Digital.
Digital thermometer. Very good. Okay. Now let's quickly understand the conversion of the scales. How do we convert from Fahrenheit to Celsius and from Celsius to Fahrenheit? You guys have already studied about these datas. Like, answer this simple question to me. Do tell me what is the boiling point of water in the in Fahrenheit scale? In previous class we have discussed that.
212 degree
Two,
Fahrenheit.
212. Very good. What about the freezing point?
32.
32 degree Fahrenheit. That's good to know. Okay. Let's understand how do we convert that. Also, we have studied about Kelvin scale also right now. Okay, for example, let's begin with this question. You have to convert degrees Celsius, 16 degrees Celsius into Kelvin. Both of you solve it separately and answer it in the chat box. You know where you have to answer.
Sir, which ID?
This one. Okay.
Okay, sir.
Solve it quickly. Once you'd be done with this one, solve this one also. This one. Solve this one also and answer it in the chat box. I will be back in a minute. Okay. Yes, I'm back. Okay, you guys done? Hello, both of you done?
No, sir.
Not yet.
No, sir.
Okay, solve it quickly. Why you guys are taking this much of time? Like the first one is very easy. First one was very
Sir,
easy.
sir.
Yeah.
Stress here for the first one.
No, don't say it. Just answer in the chat box. Okay, no? Priyanka, you have answered for the first one. No, that isn't correct. It is slightly less than the value which you have answered, Priyanka. Keep in mind the formula. Keep this formula in your mind. This is the formula you'd be using. 273 is added or subtracted while you're converting. I have shown the formula to you. Okay, do let me know if you guys need help in solving this one. Okay, don't wait that much. Do tell me, in order to convert from Celsius to Kelvin, what has to be done? To convert from degree Celsius to Kelvin, what has to be done? Yeah, Abu, that is correct. Okay, now, although even if you write, don't write the decimal value, that will also be sufficient. If you have written, no issue, that is good. The first one, both of you have answered correctly. But Priyanka, the thing is now, instead of 290, you would be getting 289 because you're required to add 273 to this. Yeah, Priyanka, that is good. 289. Okay, solve the next question. Here you have to convert from Kelvin to Celsius. You should be adding or subtracting 273 from it.
Minus, sir.
Subtracting from it, very good. So subtract this value and tell me what is the value. That is correct.
Answer in the chat box.
Yes, Abu. That is all. That is correct. Very good. Okay. Priyanka, what value are you getting? Answer it quickly. You guys also tell me, where do we use the minimum and maximum thermometer?
Weather forecast.
In the weather forecasting or in the meteorological work. In meteorological work, there we use the there we use the maximum and minimum thermometer. It has a special feature that it automatically records the maximum and minimum temperature of the day. So thereby, the weather reports that you hear in TV or in newspaper, it is actually measured by the help of the maximum and minimum thermometer. Okay, that is correct, Priyanka. Okay, let's move further. Now let's understand how do we convert from degree Celsius to Fahrenheit or from Fahrenheit to degree Celsius. See, let me add one slide over here. Okay. Now keep in mind this formula. You have to convert from 1 minute Fahrenheit to Celsius. So thereby the formula is whatever value is given in Fahrenheit, subtract 32 from it and thereby multiply it with 5 upon 9. The formula is C equals to F minus 32 multiplied 5 upon 9. When you will be using this formula? When you have to convert the value from Fahrenheit to Celsius. Fahrenheit to Celsius. Let's take an example. Let's say you are provided with a value. For example, the one which we have studied already. Like the boiling point of water in Fahrenheit is how much?
212.
12, right now? Now let's suppose you don't know what the value is going to be in degrees Celsius. Let's say, although you guys know, although you guys already know it, right now? Let's do the maths. Put the value of Fahrenheit. What is the value given in Fahrenheit here? 212. Subtract 32 from it. And then multiply whatever value you're getting with 5 upon 9. Okay, will you guys be able to do this? Yeah?
Sir.
Okay. What is 212 minus 32? Quickly. Let's see whose maths is fast. 212 minus 32. Let it be 170, 180, 190, 182, 192. What should be the value?
170.
No, not 170. Yes.
80.
See the 180. 180. Okay. 180 multiplied 5 upon 9. Okay. Now it is in multiplication. So it is basically 180. Can I write it like this? 180 upon 1 multiplied 5 upon 9.
Yes, sir.
Okay. And when you know that when fractions are in multiplication, so if the numerator and denominator cancels each other, if numerator and denominator of fractions cancel each other, you cancel them. So 180 will be cancelled by 9 by how many times? 9 cancels 180 by 20 times or not?
Yes,
9
sir.
20s are 180 now. Okay. So thereby you are left with only this number 20 upon 1 multiplied 5 upon 1. That is 100 degrees Celsius. And we know for a fact that the boiling point of water in degrees Celsius is also 100. By calculation, we found it to be same. Have you guys understood this or not? Both of you
Yes.
understood this? Okay. Solve one more question. This one you guys would be solving yourself. Say what would be this? 272 degree Fahrenheit. Convert this into degrees Celsius. You guys have understood the method, I believe. Whatever value is there, just put it in place of F and do the calculation. You would be getting the answer.
Sir,
Mhm.
is it 133?
Abu, are you also getting the same answer?
133.
Very good. Okay, no? So now you have understood how to convert from Fahrenheit to Celsius. Okay, no? That's good to know. Let's understand now how do we do the opposite. How do we convert from degree Celsius to Fahrenheit? Okay, now. So you have got another formula for that. The required formula is this one. So that is F equals to C times 9 upon 5 plus 30. Okay, now let's do this one also. C into 9 upon 5 upon plus 32. So for example, let's say that again, take the example of boiling point of water. That is 100 degrees Celsius, converting it into Fahrenheit. So it is simply going to be 100 times 9 upon 5 plus 32. So that is 5 cancels 100 by 20 times. So that is 180. 20 into 9. That is 180 plus 32. So that gives you 212 degree Fahrenheit. Isn't that very simple? Hmm?
Yes, sir.
Okay, no? From degree Celsius to degree Fahrenheit. Okay, let's do another question. Let's say that I give you a value of 175 degrees Celsius. Now uh, convert this into degree Fahrenheit. Also, don't give your answer in the class. Answer it in the chat box. Okay. After we are done solving this now, um, some questions are there, but you would be doing them as part of your assignment, or just take the screenshot. In the next class I would be asking its answer. After having studied about conversion of temperature, how do you convert it from one scale to another, you would understand about transfer of heat, how heat is transferred from one body, from one hot object to a to another cold object. So there are different ways of heat transfer. Okay, what answer you guys are getting? Is it a difficult calculation, Miss Priyanka, Abu? See, 175 times 9 upon 5 multiplied by 9 upon 5. Then add 32 to it. So see, by how many times? Yes, Priyanka, very good. That is correct. Abu, should I solve it further? Will you be able to do it?
Sir, I can do.
Good. Also, guys, in the next class or in upcoming classes, I might ask these formulas anytime. Okay, now So make sure that you revise them. Make sure you memorize them. Priyanka, define temperature. What is temperature? Yes, Priyanka, what is temperature? Abu, don't take that much of time. Solve it quickly.
That,
Sir,
Meanwhile,
means,
Priyanka, you define. Yes.
sir, should I say it in the class?
Okay, say it in the class. Yes.
temperature is the
347.
347. Okay. 347 what? Degree Fahrenheit. Both
Degree
of you have
Fahrenheit.
got the right answer. Very good. Yeah, Priyanka, define temperature, then we'll continue further.
temperature is a degree of hotness or coldness of a body.
Mm-hmm. Very good.
Temperature is measured
Mhm.
in degree Celsius and degree Fahrenheit and Kelvin.
And Kelvin. Very good. Okay, no? Very good. Okay. And how do we measure it? By using a instrument. That is called as thermometer. Okay.
Yes, sir.
Quickly get done with these questions also. The correct method of reading a clinical thermometer. Holding the thermometer by bulb before using the mercury level should be below 39. Don't hold the thermometer by bulb. None of these. Which one is the correct method? Both of you can answer in the class.
Sir, D.
None of them is correct. See, don't hold the thermometer by bulb. Yes, Abu? See, yeah, that is correct, Abu. See, holding the thermometer by bulb, that is wrong. That will alter the reading. That will give
Yes, sir.
false reading. Before reading, the mercury level should be below 35, not 39. Okay. Don't hold the thermometer by bulb. Actually, that is correct. Which of them contains mercury? Hmm. Which one of them contains mercury?
None of
C.
these.
C.
It is both now. How can it none of these, Abu? Both of them contains mercury now.
Sir, C.
Clinical and laboratory, yeah. See, when we talk about clinical thermometry, yes,
Sir, but there is digital thermometer also.
yeah, I get your point. But generally, when this question is asked now, and when you have such an option, both A and B, see what the questioner is asking you here by clinical thermometer. Generally, it means it refers to the glass thermometer, right now. So if we were to talk about clinical thermometer, there are two types. One that is made up of glass, another one that is digital. So generally, it is referring to the thermometer that is made up of glass right now. So they were both of them will be true. SI unit of temperature. Yes. Answer this one. Yes. What is the SI unit of temperature? Is it degree Celsius? Is it Fahrenheit? Or is it Kelvin? Yeah.
Sir, it's not none of them.
No, one of them is true. It's actually Kelvin. Keep that in mind.
Sir,
Kelvin
what
is the
about
what about?
Joule?
No, Joule is not the SI unit. Joule is also used, but Kelvin is actually the SI unit right now. SI unit is the SI unit of temperature is Kelvin. Getting it? We represent heat in joule also, but the talking about the SI unit, that is Kelvin. Okay. Now see, in nature you have different objects. Some of the objects are good conductors of heat. They allow heat to easily pass through them. Usually the metals. Yeah. So metallic objects are said to be good conductors of heat. Conduction basically here refers like the rate of conduction of heat is different in different solids. Materials that conduct heat easily are called as conductors. So here by conduct, it means that whether it allows heat to pass through it or not. So metals allow heat to pass through it. So thereby it becomes warm, it becomes hot, right? While so they will be called as conductors of heat. What do we call them as?
Sir, is
Conduct.
this
Yes.
the materials which allow heat to passes through them
Exactly.
easily?
Mhm. Exactly, Priyanka. That's what we are talking about. Like,
Okay,
have a look at this image. Like copper, aluminum, gold, they are good conductors of heat, right? Now,
yes, sir.
then you have example of iron also. We can count the iron in it also. Iron, steel, those are good conductors. They become hot. While you have objects like wood, cotton, rubber, or clay, or the cork of this that is used in this tennis, or it is used in closing the bottle, like in the bottle. So the thing is that they are poor conductors of heat. They do not allow heat to pass through it easily. Air and water are also poor conductor of heat. Now try to understand this thing. For example, let's say this thing that I have taken a metal rod and I have taken a piece of wood. Now say that both of them are being heated. I am heating both of them. This one and this one is also being heated. Say that this is end A, this is end B, this is end A, this is end B. The first one is a conductor of heat. Another one is a bad conductor and it is called as insulator. Do tell me in which case the tip B, the end B will become heated quickly. The tip B, I mean to say the end B becomes heated quickly in which one?
Metal rod.
Yeah, isn't that true, Abu? So the reason why it became heated because this metal rod allowed the heat to pass from A towards B. It allowed the heat to pass from it, right now. But usually, does it happen like if you were to hold a stick in the fire, will you also feel warm at the other end of the wood?
No, sir.
No.
No. So it's a very bad conductor. The rate of transfer of heat is very slow. So that's why we use the term conduction. The conduction of heat is good in the case of metal, while in the wood it is very poor because heat is not transferred from one end to the another end. Getting it now? So you have examples of like wood or plastic or styrofoam or rubber. These are examples of materials that do not allow heat to pass easily through them. So thereby they are called as bad conductors of heat or simply insulators. Right? Let's understand about transfer of heat. You guys have already studied about basics, like to carry heat from one part of an object to its other part or from one object to another object, you have to energy is transferred. Whenever there's a difference in temperature of two bodies, you have one hotter body, you have one colder body. So heat transfer from hotter to the colder body. So transfer of heat is basically what? To carry heat from one part of an object to another part or from one object to another object. That is called as transfer of heat. and heat energy always flows from a region of higher temperature to a region of a lower temperature, right now. And till when it will happen, like in this case now, heat will start to flow from A towards B till both the end of this metal rod acquires the same temperature. Let's say this also becomes 80 degrees Celsius, and right now it is, let's say, 40 degrees Celsius. So heat will start to conduct from A to B till the temperature of B also rises to 80 degrees Celsius. You guys getting my point?
Yes.
Yes.
Okay, no? So that is the thing. And this phenomena, as I said, this is called as transfer of heat, right? So that is the thing. Also, in general, you have studied heat flows from a hot object to a cold object. Or in other words, we can say that heat flows from an object at higher temperature to another object that is at lower temperature, right now. And when will it stop? When the heat flow will stop? When transfer of heat stops? Yes. Answer this question. When will the flow of heat stop?
Until they reach.
Until both the body attains the same temperature. Getting it?
Yes, sir.
So that is the point. Okay. See, for example, does it mean that no heat will be transferred from one object to another if the temperature of two objects is same? For example, let's say that you have an iron ball. Let's say you have a ball made up of iron, and let's say that it is having a temperature of 40 degrees Celsius. Iron ball, the temperature, let's say it is 40 degrees Celsius. And now let's say I am dropping it in a bucket filled with water. Say you have an iron ball which is having a temperature of 40 degrees Celsius. It is dropped into a bucket containing water, and this is also it is also having the same temperature. That is the twist. It is also having the same temperature, that is 40 degrees Celsius. Then heat will not flow either from iron ball to water or from water to the iron ball, because the reason is that both of them are having the same temperature, isn't it?
Yes, sir.
This is
Yes.
falling over here, but heat transfer will not take place, so thereby no heat transfer. So hope that is clear to both of you. Another thing we are going to be studying here, what are the various ways in which heat can be transferred from a hot object to a cold object. So heat can be transferred namely in these three ways: conduction, convection, and radiation. In fact, it's a phenomena that is happening 24 hours. It is happening all throughout the year. Every time you see, like, even look at different things at your home, at your house, and you around yourself, everything is either there will be conduction of heat or convection or radiation, or all three of them will be happening at the same time. Hmm? You guys experience this on a daily basis. Let's understand how. First of all, let's talk about uh, conduction. First of all, you'd be talking about. First of all, let's talk about conduction. See, if you have we have the same example of this metal rod, or see that you had the example of a spoon, metal spoon. Hmm? So, for example, have you guys ever hold a metal spoon over a gas burner, like you tried to boil something? Hmm?
Yes, sir.
Or hold some other kitchen utensils over the gas burner? So what you observe that the
It's
end of the spoon that you are holding, that also becomes
hot.
hot. So in this case, how the heat is transferred from the hot end of the of that metal spoon to the cold end which you were earlier holding? How did it
Condensation.
transfer? That is,
Condensation.
condensation is a different thing. Condensation is cooling of water vapor. It is conduction. Okay, no? And conduction is seen to be taking place only in the case of solid objects. Right now? So in that, what was happening? The heat is transferred from the hotter end to the colder end. From the hotter end to the colder end. You can look at this image and you can observe this one thing. It looks like something is sticking to this metal rod. Yeah, something is sticking to this metal rod, and after some time you will observe that it starts to fall. Right now, this end is slightly hot. This end is slightly hot. Now after some time, this end will also start to become hot. So something that was sticking to this end, due to the rise in temperature, it detached from it, so it fall. Heat rises further, this also started to fall. So and heat will start to continue flow through it. Right now, let's understand like what exactly is happening, how heat is flowing in this solid object. As I told you, conduction will be only observed in the case of solid substances, not in the case of liquid, and neither in the case of um, gaseous objects. Okay, now keep that thing in mind. Now, if I were to talk at a molecular level, I know that every objects are made up of atoms. Now, everything, not just everything that you see in the universe, everything is made up of atom or not.
Yes, sir.
Humans also.
Exactly. We talk about cells, like say that this is a cell. Cells are what? Cells are also made up of atoms. Hmm? Inside the cell, you have different things. You have nucleus, you have cytoplasm, you have mitochondria, you have endoplasmic reticulum, you have chromosome. Everything that is inside the cell, they are also made up of atoms. So atoms are even tinier than the cells. Okay, now? So atoms are tinier than everything you can think of. Getting it now? So see what happens. I know that there would be millions and millions and millions of atom present inside this, isn't it? This metal rod will be made up of millions of atoms. Right now, just to for the convenience of understanding, let's say I have drawn few atoms. So once I start to heat this end of this metal rod, these atoms are actually gaining the heat energy. Heat is a form of energy, you know that, isn't it? So the
Yes, sir.
atoms are getting energy. What happens when you gain energy? When you are having too much of energy, you play a lot, you move here and there, and you do um, lots of activities, you play. Yeah, when you are full at energy, when you are feeling lethargic, you simply go and sleep. So the atoms are getting lots of energy from this candle flame. So it will start to shake. What happens? It starts to shake. Getting it now? So while shaking, it transfers its heat to the nearby atoms. So this nearby atom also gets energy. So this will also start to shake and transfer the energy to the next atom. This will also start to shake and transfer. So all the atoms, you see, all the atoms are connected to each other, and energy from one atom will be transferred to another atom, and it will keep on transferring until it reaches the end, another trip. It until reaches the another end of the metal rod. Is
Sir,
that clear to all of you? Yeah.
this will could also happen because of like while uh, if if it is heated, then if a metal is heated, then it will like become small, right? So then it could, because it is while it is becoming small, it is moving, so it could also, the sand could also drip out like that.
That is the thing now. Because of the rise of the heat, say that you have attached some sticky substance to it. So because of the rise in temperature, this starts to fall. While this main reason how basically is heat starts to travel from one place to another, one into another, I hope you guys have understood this part. While we were discussing how atoms will transfer energy to another atom, and this will also transfer its energy. Priyanka, Abu, that is clear?
Yes, sir.
Okay, so
Yes,
atoms
sir.
start to shake and thereby they transfer the energy. Okay. Priyanka, read the given paragraph.
Condensation.
Conduction,
Condensation.
conduction. It's not condensation.
Conduction is
Mhm.
the transfer of heat from a hotter part to the colder part of an object due to
Collision,
collision collision of its par-
particle. Hold on there.
particle
Hold on there. Collision
partic-
here, basic. Yeah, 1 minute, 1 minute, Priyanka. When we say collision, collision is basically that they are. Um, just guys, give me 1 minute. Hold on for a minute. Um, I will be back in just 1 minute. Okay, now. Meanwhile, Priyanka, you keep on reading this.
particle without actual movement of a particle from their position. Heat transferred through conductors occurs within solids and between solid substances that are in indirect contact with each other.
Yeah, sorry for the interruption. There was an important call coming. I had to pause. Yeah. See, I was talking about this collision over here. Abu and Priyanka, pay attention. Collision here means that when two objects collide into each other, when two objects crash into each other, right now? When two objects are vibrating and they collide into each other. So didn't I told you like these particles over here? Is my screen stuck?
No, sir.
Okay, huh.
No, sir.
Okay. So the particles are actually here the atoms. While we talk about particles, what particle we are talking about? We are talking about the atoms. So atoms are actually colliding with each other. The two atoms, they collide with each other. They collide with each other. And due to the collision, the heat energy is transferred from one particle, meaning from one atom to another. While it's not like all the atoms that were heated up, it went to this part. Is it so that the atoms of this end of the metal rod, all of them went away from here to here? No, they remain at their actual place. They have been remaining at this actual place, and they are vibrating, and thereby they are striking the next particle. It also vibrates. It again strikes the next particle. Like that, heat is transferred. It's not like this atom gets up from here and goes to this part. So the atoms are not actually moving from its place. Getting it, guys?
Yes, sir.
That line is very important. Without actual movement of the particles from their position, right? And where in which substances heat will be transferring through conduction? It will be happening within the solid objects or between two solid objects. Like it is happening within this solid object or within this one. While if you have two solid objects that are in contact with each other, there also it will be happening. Getting it? Now, like for example, your hand is a solid object. Your hand is solid. You hold something that is hot, like you hold something that is hot, that is solid in nature. So there also heat will be transferring. So that is the thing. And sometimes we call it as thermal conduction also. Thermal basically refers to heat. That is heat conduction. You can look at the direction of flow of heat from the source of heat towards the colder end of the object. So hope that is clear and you guys have understand how does conduction of heat occur. So I'm supposing you guys would be able to explain this. Do tell me, both of you understood conduction or not? Conduction is the transfer of heat from the hotter part of a material to its colder part, or basically from a hot material to a cold material in contact
So
with it.
in a colder end,
Yeah. Mhm.
hotter end to the colder end.
Exactly. And without the actual movement of the particles of the substance, right? So in all the solids, heat will be transferred by the process of conduction. Keep that in mind. Okay, no? Okay. And another thing, actually, in this one, I forgot. Actually, these were small iron strips that were attached to it. Or in anxiety, you might find that there will be iron nails that are attached to this. Okay, no? Anyways, so we
Sir,
can do the activity also to show conduction of heat. Yeah, Priyanka.
I have one doubt.
Yeah.
So atoms, right?
Yes, atoms. ATOMS.
It is also known as moleculums. Molecule.
Mhm. Note. See, when two atoms are joined, two atoms of the same kind are joined together, then it is called as molecules. For example, say that you have oxygen atom.
Okay, sir.
Say that I have two oxygen atom. So the thing about the oxygen atom is that they never exist alone. They always join together. So they will join together. So thereby it becomes a molecule. These were two oxygen atoms. They don't stay alone. They stay in contact with each other. Like this, they are in contact. Then we call them as molecule. While
Because
when
in
we talk,
school, I learned molecules, sir.
like we can use the term molecule also. Like what is this iron rod made up of? This is made up of this rod is made up of iron,
Yes, sir.
right now. So inside this rod, what you will find out, you have iron. So iron molecules would be connected with each other now. Like irons, the atoms do not exist alone. Keep that thing also in mind. So it is actually all the atoms would be joined together and then they would be moving. Hmm? So when atoms join, when two or more than two atoms join, thereby you have molecule.
Okay, sir.
Like when I write O, it means simply oxygen atom. But when I write O2, it is oxygen as a molecule. So there could be several atoms that can join together. For example, you have sulfur. Sulfur is S8. 8 atoms of sulfur join together to form a molecule. You guys getting my point or not? Hmm? So to understand it in a more better manner, you can understand it like this. Let's say that the atoms would be joined together like this. They would be in a molecular state. And then again, they will be vibrating and the heat would be transferred from, you can say molecule also, like energy will be transferred from one molecule to another one. Getting my point or not? So for the sake of convenience, we say atoms, you can say molecule also. right now. And then we have also studied this thing moments ago. Like there are some objects which are good conductors of heat, some which are bad conductors of heat, right? The conductors and insulators which we have studied moments ago. Okay. Let's
Sir,
understand. Mhm.
sir,
Yes,
I
Abu.
also have one doubt. Sir, my teacher said that
Mhm.
like why is too too thin woolen blankets more hotter than one
Thick
thick
blanket.
blanket.
Mhm. I think we did discuss that thing in one of the class. I believe we did discuss that thing in one of the class now. See, while we were talking about conductors and insulators, we came across insulators also. So thereby I told you that air and water are also bad conductor of heat. Okay?
Yes,
Air
sir.
and water are also bad conductor of heat. See what happens now. In the winter night, if you were to wrap yourself using too thin blanket, what happens? A layer of oxygen gets trapped between the blankets, and air is a bad conductor, meaning that air will not allow the heat to pass through itself. Like metals, which is a good conductor, it is a good conductor because it allows the heat to pass from one end to another. Right now, while you have air, what it will do? Say that this is some amount of heat, so it will not allow heat to pass across it. It will hold the heat. Hmm? That's why you see that some of the planets are very cold because there is no air in some planets. So air is a bad conductor of heat. Whatever heat is coming from the planet Earth, or from the different activities which you are doing, hmm, you are burning different kind of fossils, fuels, different type of industrial activities are releasing lots of heat. The air conditioners which you have at home, that also releases lots of heat. So all those heats, it is not lost into the space. It is being trapped by the air, that is the atmosphere. If suppose air was a very good conductor of heat, so what will happen? All the heat will pass from the atmosphere of the earth into the space. So thereby the earth would be a very cold planet. So what happens now, Abu? You use a thick blanket or you use two thin blankets, one over another. So air will be trapped between that. Air is trapped between that. And that does not allow the heat to pass through it. Getting this thing or not?
Yes, sir.
Abu, you understood this point? Hello?
Yes, sir, I understood.
Okay. So that is the thing. Okay, so in the next class, you'd be studying about what are the applications of conduction. What are the practical applications of conductions in our daily life?